Alright, question number 10. Alright, so the topic we're covering here is buoyant force. So buoyant force equation on buoyancy. So we're talking about the buoyant force, what is the equation, and so on. So let's run through what the Janine The Tutor responded here. When an object is immersed into a liquid wholly or partly, so if you have some liquid, so let's say you have the liquid, something like this, so we'll see the liquid is down here. So this is the liquid. I'll actually erase this. We have some object either down here, fully immersed, or if it's like partly immersed, we'll have a buoyant force. So this is kind of, here I'll use a different color. So this is the liquid. We have an object. I just drew a box to represent this, either if it's completely submerged or partly. We have an upward force, so a force acting upward. Call this FB. Similarly here, FB. And that's the buoyant force. So according to Archimedes, this buoyant force is equal to the weight of the liquid displaced by the portion of the body inside the liquid. So this is key to know. The buoyant force is equal to the weight of the liquid displaced. So we're only thinking about the liquid displaced by the object, by the portion of the body. So if it was half the object, we are only looking at half the volume on the bottom, or if it was the full object, we're looking at the full volume of the object. Now the question comes to mind that what much liquid is displaced by the body? How much liquid is displaced? So how much liquid is displaced by the body is the volume of the body inside the liquid equals the volume of liquid displaced by the body. So essentially what this is saying is for any object submerged, the volume of that object will be the same as the volume displaced by the object onto the liquid. So from this, we can conclude buoyant force is equal to the weight of the liquid displaced. So this is the key things right here. So the volume of the body inside the liquid. So we have some object over here. We have a volume, whatever it could be 3 meters cubed. Is equal to the volume of the liquid displaced by the body. So whatever it displaces, that's the volume that we care about. So if this was half, we'd look at 1.5. If it was full, it would be 3. From this, we say buoyant force, so FB, this is equal to the weight. Weight is measured in newtons, so weight of the liquid displaced. So weight of liquid displaced. That's the key thing you want to know here. Okay, so finally we get to the formula. So the formula here is FB. So I'm going to write this in green. FB is the density times the volume times gravity. So this is really the formula. This is how I write it. Here they wrote it a little differently. So B is just capital B, buoyant force, similarly over here. Density is shown here. And it's the fluid density in kilograms per meters cubed. It's this symbol represented here. It's like a P. I forget the name of the Greek name. And V is the volume, displaced body volume of the liquid. So this is important to know. It's not the full volume. So if it's half submerged, it would not be the full volume of this object. It would be just half. If it was fully submerged, then it would be the full volume of the object. And G is just standard acceleration due to gravity. And the buoyant force always acts upward on the object. So when the object's going into the liquid, the buoyant force is the force acting upward. So let's say we were given the density, given the volume of the object, given the gravity, and we're asked to, we know gravity is 9.8 meters per second squared. Let's say we're asked to calculate the buoyant force for an object that's submerged 3/4 of the way, right? So what we do there is we take 3/4, multiply that by the volume of the entire object, and that gives us this variable v. We're probably given the density, and we know gravity. We multiply those through, and we end up with the buoyant force. One thing to note is buoyant force is measured in newtons, so that's important to note as well. Any force essentially is measured in newtons. Alright, so answer is correct. Let me just write a comment here. Great work. Alright, so I think that's all I want to say for this question. We'll mark this question as correct, and we'll move on to question number